Good morning or afternoon, depending on what period it is. As promised, I'm not here today. I hope everybody had a great Thanksgiving. Sorry that I have to miss such an important lesson, that I am at a conference. I will be back tomorrow. I gave us a little preview of this on last Monday. So this is just a refresher with a little bit added, a little bit more practice, and we will revisit this tomorrow. So our learning target is I can solve a quadratic equation by using the quadratic formula. Factoring and graphing are ways to solve quadratics, but they won't always work. The quadratic formula will always work. The first thing you have to do is figure out what A, B, and C are. A is the number in front of the x squared, B is the number in front of the x, C is the constant. Good news is you get to hear me sing. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, as discussed last week, I'm going to use my calculator. I'm going to type that in. And I'm going to get 8 squared minus 4 parentheses, 1 parentheses, 12. And you get 16. Always just type that in what's underneath the square root. I don't put the square root symbol. You'll see why in a little bit. That gives me negative 8 plus or minus the square root of 16 over 2. And hopefully we all know that the square root of 16 is 4. Now I'm going to separate this into two parts. Negative 8 plus 4 over 2, which gives me negative 4 over 2, or negative 2. That's one of the places that this quadratic is going to cross the x-axis. Then I'm going to do negative 8 minus 4 over 2, which is negative 12 over 2, or negative 6. So my answer is x equals negative 2, comma, negative 6. That's not an ordered pair. That's just telling me the x values where it's going to cross the x-axis. So if I graphed x squared plus 8x plus 12, it would cross at negative 2 and negative 6. I'm going to do the same thing for B. But before I can get my C, I have to set this thing equal to 0. So if you get one and it's not set equal to 0, you're going to have to add or subtract, whatever the case is, to move everything to the left-hand side. And now I know that C equals negative 7. So now I can do my quadratic. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Just like before, we're going to put that in Desmos. I feel confident you can do that, so we're going to move ahead. That gives you 81. When you put 5 squared minus 4 times 2 times negative 7, you get 81. 2 times 2 is 4. And then you just have to keep simplifying. X equals negative 5 plus or minus 9 over 4, because the square root of 81 is 9. And that's negative 5 plus 9 over 4, which is 4 over 4, or 1. Then you get negative 5 minus 9 over 4, which is negative 14 over 4. Which reduces to negative 7 over 2, because 14 and 4 are both divisible by 2. So I get x is 1 and negative 7 halves. C, A equals 1, because it is assumed 1. B equals negative 3, C equals 1. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, I say negative in the song because it goes better, but truly, it could be opposite of b, okay? It could be the opposite of b. And since b was a negative, the opposite of b is positive. The opposite of negative 3 is positive 3. Now, I'm going to show you how to type this one in because it is super important that you put that negative in parentheses. If you don't, you will not get the right answer. Negative 3 squared without parentheses is negative 9. Negative 3 squared with parentheses is 9, which is the value that we need. So this is 3 plus or minus the square root of 5 over 2. I'm sure you already know this, but the square root of 5 is a decimal. It's called an irrational number because that decimal actually goes on forever. You think that might be more difficult, but it actually makes it easier because that's as far as we're going to go. We're not going to approximate the 5. Our answer is just going to be x equals 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. And that's because this formula gives us both parts, plus and then minus. So there are two answers, 3 plus square root of 5 over 2 and 3 minus square root of 5 over 2. Now here's what I want you to do. I want you to pause the video, work out the problems, and then check. Any of these that you don't get right, you need to ask me about tomorrow. That'll be a good introduction to the class so that we can kind of revisit the things you are still confused on. So pause and then come right back. If you got x equals 4 and negative 1, you did great. If not, you need to ask me about it tomorrow. If you got x equals 1/2 and negative 2, you did great. If not, ask me about it tomorrow. And if you got x equals 6 plus square root of 20 over 2 and 6 minus square root of 20 over 2, you did awesome. Ask me about it tomorrow if you didn't. All right, one last thing. We have a word problem, but we are going to use technology for this. It says the height above the ground in meters of a model rocket on a particular launch can be modeled by the equation h equals negative 4.9 t squared plus 102t plus 100, where t is the time in seconds after its engine burns out 100 meters above the ground. When will the rocket be at 200 meters above the ground? Separate answers with an or, so Alex is going to make you put an or in between. When will the rocket hit the ground? Round to the nearest hundredth, you may use technology. So we're going to graph this thing. And Desmos does not love h and t, so I'm going to use y, excuse me, for h. And I'm going to use x instead of t. But they use h and t. H is for height in meters, t is for time in seconds. I'll fix, I see that I have an extra negative in there. I'll fix that in 1 second. And there we go. Problem is I can't see it, and I don't have a table to help me decide on what I should do with my wrench. But I'm just going to estimate, and I may have to change it a couple times. Okay, so I'm going to try. X is time, so I'm just going to go with like 50. I think that might be wide enough. But for my Y, I'm not sure how high this rocket's going to go. I know that it goes at least 100 feet because that's my Y-intercept. So I'm going to go to like 500, see if I can see it. Can't, but it looks like it's not too far up. So I'm going to try maybe 750. And there we go. Now I can see it. I can see all the parts. Now the first part of the question is, when will the rocket be at 200 meters? Well, remember the height was y. So if I just put in y equals 200, I can click. And after 1.03 seconds, or, because it does it 2 times, it does it on the way up. Here's the rocket going up. And then it also does it on the way down. So on the way down, it does it after 19.78 seconds. The second part of my question asks, when will the rocket hit the ground? Let's get rid of that y equals 200. So again, here's my rocket going up, up, up in the air. There's the highest point. So it reaches almost 631 meters, not feet, sorry, meters after about 10.4 seconds. Well, here it is going down, 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 down. And when it gets to a height of 0, that's when it hits the ground. So the second part of this question is it hits the ground after 21.75 seconds. All right, you have an Alex assignment. Okay, so you're going to go to Alex, you're going to finish that assignment. I'll be back tomorrow. We're going to go over this again tomorrow with the Desmos activity. I'll be able to answer any questions you had over the try-its. I hope you didn't miss me too much, and I will see you tomorrow.